All right, so powers and exponents. That when they talked about having the powers, basically you have a large value and then a tiny written value in the corner. That is called an exponent, that tiny value. So if we're taking a look at the following, if I've got 5 and then a 3 for the exponent. Okay, this 5 right here, let me zoom in a little bit more so you guys can see it easier. This 5 is called our base. So whenever you hear me talking about base, this is what I mean, the 5 in this case. And then that little number in the corner is called the exponent. Okay, and then remember that your exponent tells you how many times the base is used as a factor in multiplication. Okay, so it tells how many times the base is used as a factor in multiplication. Okay, so this 5 to the third power can also be written in what's called expanded form. So this right here is exponent form or exponential form. Then you've got a expanded form, which means that you're actually writing it out. So 5 times 5 times 5 again. Okay, there should be 3 5s written here. Okay, which obviously has a value. It does equal a number. It equals 125. When we are reading out a number in exponent form, every number has an exponent. If I just write 5, that automatically has an exponent. The exponent here would be a 1, which in the video they said, oh, 1 really didn't do anything. It didn't have any kind of power to it because it just kept the number as it was. It kept the base. Okay, so every number has an imaginary, or not imaginary, an invisible exponent written, and that's one of the things that we have up on our invisible math board in the back. If you look at the very top row, the green sheet, so there is a power of 1 for every number. Every whole number has a power of 1. It just doesn't have to be written. So 5 to the first power is how we state it. 5 to the first power. If you're reading out or saying it out loud, you would say that this is 5 to the first power. If the exponent is a 2, there's 2 different ways that you can actually say it. And so I'm going to put a star next to it. There's 2 different ways that you can say this expression. You could say 5 squared, which is the more common one, or 5 to the second power. 5 squared, again, is the more common lingo for it. Same thing when you have an exponent of 3, so I'm going to put a star next to that one as well. This has a special way of saying it. It would be called 5 cubed. That's the most common way that we say it. Or you could also say 5 to the third power. Now, anything beyond an exponent of 3 is all based off of, blank to the blank power, the 5th power, the 20th power, the 18th power. Okay, it all is written in that sense. They don't have any kind of special way of phrasing it. So like again, if I say 5 with an exponent of 4, that just is going to be 5 to the 4th power. And it keeps going on and on and on like that. Okay? Now, writing things in exponential form. Okay, meaning that we're looking at a series of repetitive multiplication and we want to simplify it to where it's just a single base and a single exponent. There are a couple of things that you need to make sure you have in mind first so that you know. So first of all, if I say -4 and put it in parentheses and put it to the second power, square it, versus -4 but not in parentheses to the second power, are those the same thing? How many of you think that those would equal the same value? Okay, Kaden thinks that they would. Eric thinks that, okay, a few of you think it will. How many of you think it will not equal the same value? Okay, so got a few that don't think it will. So what I want you to do is think, why do you think it would equal the same value? And those of you who don't believe it will, why do you think it won't? And I want someone to share their argument, your thought process. Why do you think it will, or why do you think it won't? Who's brave enough to share? So Devin, do you think it will or won't? You think it will? Okay, so why do you think it will? Huh? Yeah, why do you think that they'll both equal the same number? You don't think they will. Why do you think they will not then? You think the parentheses is going to give you a positive number? Why do you think that? But do you know why? Okay, so Devin's right. It won't equal the same thing. The reason why this is going to give you a positive number and this one is not is because here, when you've got parentheses around it, it's not just the 4 that's raised to the second power, but it's also the negative sign that's raised to the second power. That means both of these are going to be in repetitive a repetitive amount of multiplication. So if I were to write this out, this would be written out as -4 times -4. And as we know, a negative times a negative is going to equal a positive. Right? Whereas for here, and I'll do this one in a different color, we'll do it in orange. For this one, -4 not in parentheses to the second power, the only thing that's actually being repeated is the 4. That exponent only belongs to the 4 and not to the negative sign. So the negative sign is going to come out, and then you've just got 4 times 4. Okay, and I can put that in parentheses. 4 times 4 is 16, but the negative sign is on the outside. So you get a -16. So these things are not going to be the same. They're actually not equal to each other. Okay, this is also true for one other concept. So not just negative bases, but also bases that have a fraction. So if I've got something that says 2/9 and I'm raising this to the second power versus 2/9 not in parentheses raised to the second power, these are also not going to be the same. Why? Think through. What do you think is going to cause it to not be the same? Think about here. By having the parentheses, it included the negative sign as well as the 4, versus not in parentheses, the negative can no longer be included in that repetition. What do you think is going to happen here, Eric? Very good. Eric said, okay, when it's in parentheses, that exponent is now going to belong to both numbers, the numerator and the denominator. But when it's not in parentheses, that exponent now only belongs to the numerator. It only is going to extend to that top value and not to the denominator. So in a problem like that, you need to be careful if you have repetitive fractions for your multiplication, then you have to include that base in a parentheses when you're writing it as an exponent. Okay? So again, for here, 2/9 inside parentheses to the second power, that can be written as 2/9 times 2/9, which would then come out to 4/81, versus 2/9 not in parentheses, that would come out as 2 times 2, all of it over 9, which would then be 4/9. Again, these concepts are not equal to each other. So you need to make sure you're aware of when to use parentheses versus when not to. And when you're evaluating in exponential form, you have to be aware that sometimes that negative sign's included, sometimes it's not. Sometimes the whole fraction is included, sometimes it's not. Okay, so let's go ahead and do a couple of problems where you're going to translate from expanded form into its exponential form. So I'm going to go ahead and flip to the other page, okay? So we're going to write the following problems in exponential form. You don't have to evaluate it. You're just going to put it in exponential form. Again, you're not going to evaluate, you're just going to go ahead and put them in exponential form. All right, let's go ahead and go over this. So for problem number 1, who can tell me? Aaliyah? Four to the 5th power. So 4 to the 5th power, right? We have 5 times that the 4 is going to be repeating. 1, 2, 3, 4, 5. So this is going to come out to 4 to the 5th power. 4 to the 5th power. What about problem number 2? What would problem number 2 look like? Anybody? Jair? Very good. 3 squared times 6 to the 4th power. We have the 3 repeating twice, so that becomes 3 squared. times, so we have another base, a different base, 6, 1, 2, 3, 4 times that is repeating. So that would be 6 to the 4th power. So 3 squared times 6 to the 4th. What about problem number 3? How would we write problem number 3? Briley? You could. However, there is the 2's repeating, isn't it? So remember, if we only have one of them written as a negative, then what do we make sure we do? Leo? Huh? Sure. Okay, she already said that. Yeah. So you could write it that way, but there's a different way to write it. Yes. Negative 2 to the 4th power without parentheses. There would be no parentheses. If you just write it as negative 2 to the 4th power, that 2 is repeating 4 times. The negative is only 1 time. So that means you would just write it without parentheses. So I'm going to write it off to the side here. It would be negative 2 to the 4th power, since that's kind of looks a little wonky there. Okay, so that would be without parentheses. Yes, you technically could write negative 2 times 2 to the 3rd power, but if you wanted to write it as shorthanded as possible, this would be the proper way to write it. Okay, what about problem number 4? How do we have to write number 4? Eric? Very good. Inside parentheses, we would write negative 5. Outside the parentheses, you would have an exponent of 6. The negative 5 is repeating this entire time, and it repeats 6 times. So not only the 5 repeats, but also the negative repeats. So since the negative is repeating with it, you have to include it inside parentheses. What about problem number 5? How could we write number 5 in exponential form? Ethan? Good. M to the power 3, or m cubed. You could say m cubed. So we have m, the letter m, repeating 3 times. So we could write m to the 3rd power. And then the letter n is repeating twice. So we could write n squared, or n to the 2nd power. So m cubed, n squared. What about problem number 6? Aaliyah? To the 3rd power. Good. So in parentheses, it's very important. She said that. In parentheses, you have to include the entire fraction, because the entire fraction is repeating. So in parentheses, you're going to put 4 to the 7th, 4 over 7. Outside the parentheses, you're going to put the 3rd power, or cubed. Okay? What about the last one, number 7? How do we have to write number 7? Bonnie? Very good. 3/11 to the power 4 without parentheses. You don't have to have parentheses at all when writing that one. Only the 3 is repeating. So therefore, when you write it as a fraction, 3 over 11, since only the numerator is repeating, the exponent is only going to go on the top. It's only going to refer to the top. So you don't even have to put it in parentheses. Okay? All right, and then let's go ahead and work on actually evaluating a few of these. So evaluate means to figure out what it would actually equal. Okay, so let's say we have negative 5 in parentheses to the 4th power. I want you to fully evaluate that. You can use your calculator, obviously. And real quickly, let me show you where your exponent button is on your calculator. So here on our calculators, and the screen's a little bit dark to see, but on our calculators, in order to be able to do the exponent button, if I wanted to type in negative, let's say negative 7 to the 8th power, and it's inside parentheses. Here's your parentheses. Okay, these two values right here are your open and close parentheses. So I'd hit parentheses first, and it'll show up. Then negative, remember this is your subtraction sign, this is your negative sign. I would type in negative 7, and then I would close parentheses. Again, on the screen it shows negative 7 inside parentheses. And then I want to make an exponent. Now, if my exponent is just a 2, then this button right here would give me the exponent of a 2. See? But I don't want to have a 2. I said I wanted to have an 8. So in order to be able to create an exponent other than the 2, the button right above it, that little tiny arrow that looks like it's pointing up, what that does is when you press it, it then creates a flashing cursor box that is in the exponent spot. I would then type an 8. I would now need to get out of it, because in case you come across a situation where you're doing more than just this problem, maybe I'm doing this problem and then I'm adding 17 to it. Well, I can get out of there and finish typing whatever the rest of my problem is. But this is how you would set up an exponent. You would use that up cursor arrow right here and then type whatever your exponent is. Then once you hit enter, it will evaluate it for you. Okay? So I want you guys to go ahead and evaluate a couple of these problems. So we have negative 5 to the 4th power. I have 6/7 to the 2nd power. And then I have negative 5 to the 4th power without parentheses. And I have 6/7 to the 2nd power without parentheses. Go ahead and evaluate those. All right, Kaden, what did you get for problem number 1? 625. So that negative 5 is going to be included in parentheses. So when you evaluate it, it does come out to a positive 625. I'm going to skip down to problem number 3. Aaliyah, what does problem number 3 come out to? Negative 625. When that negative is not included inside of a set of parentheses, then that means the entire answer is going to be negative at the end. All right, look at problem number 2. Problem number 2. Leah, what did you get? 36 over 49. Very good, because that means that 6 is raised to the 2nd power, and so is the 7. The 7 is also raised to the 2nd power. So you get 36 over 49. Versus number 4, what does number 4 come out to, Amy? 36 over 7. When you aren't including in parentheses, only the 6 is raised to the 2nd power. The 7 is not. Okay, any questions about today? All right, so what you're going to be doing now is you're going to grab your computers. And in Google Classroom, I have gone ahead and assigned 4 IXL skills. All need to be done to what SMART score? 70.